Thank you. And great session, Malay. I know probably I'll do a bit of justice after this because we are going to get deeper in terms of how do we go ahead and build the AI infrastructure. I'm from Cisco, and I do this day in, day out, helping customers understand that how do you define your infrastructure, how do you define your use case. I'll start off with what Malay asked us to think about, that if you ask the right questions, only then you will get right answers, okay? Start off with a small story. We all heard about James Watt, who built the steam engine, a bit geeky, electrical engineers, show of hands. Yeah? Thank you. So when he built the steam engine back then, okay, there were coal miners who were going into the mines using horses to go ahead and serve that, okay? He built the steam engine. He started off, this is the best condenser, this is the best compressor. And people went, what? Are you talking about condensers, compressors, and so on and so forth? I don't understand any of this thing. James Watt went back to the design board. He came back and told to these coal miners that you would replace 10 horses with this steam engine. What that meant is you don't have to think about fatigue of horses, you don't have to maintain the horses, and boom, then the coal workers understood. What's the moral of this story? That you need, in AI wave, there's a lot of things going on. Back in 2022 when this all started, there were about 350K models. And since then, every 6 months we publish 350K models. It's important to understand what works best for your organization, what resonates, only then you'll be able to reap benefits. That's my session about. That how exactly you build an AI strategy for your organization and then define the infrastructure journey for this overall stack. What we'll talk about is operationalizing AI. I know when people hear about Cisco and an infrastructure company, they think that we are only going to talk about networking stack. It's not that. We'll talk about network. But before that, let's get into details of how do you operationalize AI journey. Then obviously networking is our bread butter. We will talk about network design, security, and we'll end it with a secure AI factory. Now, getting into operationalizing AI, a few of you would be thinking, why are we talking about operations in the first phase? Generally, you talk about the product and then you talk about the operations. But this is from an operationalizing perspective, understanding how do you define an LLM, how do you size it, and then import it on your infrastructure stack. So it's important to understand and break down how would you operationalize your AI journey. Now, a bit of peek, I think Malay covered this, but I want to give a different spin. We all heard about bell curve, talking about modernization journey, infrastructure modernization, virtualization platforms, VMware, Nutanix, and so on and so forth, Kubernetes. That followed a bell curve. What does a bell curve indicate? That there are few early adopters, then people wait, hey, is this working? If this is working, then we'll adopt. So that's where people generally adopt at a cycle when it is peak. But in AI era, right from 2022, in the launch of ChatGPT, ML was there from a long time. But with generative AI, we are seeing a tectonic shift in adoption, right? We started off with ChatGPT, then there was reasoning model, which is DeepSeek, then assistants, agentic AI, and now we're talking about physical AI, right? So what does this mean is from a technology perspective, we would no longer see a bell curve. We'll see an S curve. By the time you think you want to adopt it, you would already feel that the technology is moved. If you're talking about RAG, then people are talking about agentic AI. If now on agentic AI, we are talking about physical AI. So in this particular journey for AI, it is important to start your journey today. It's better to start your journey today and go ahead and operationalize it better versus playing the wait game and waiting for technology to just evolve. Because a year down the line, we don't know how things will go. We'll have all physical AI taking up the space. We would also need to understand that there are architectural shifts when you go ahead and implement generative AI as part of your organizations. There are inference-led repatriation. When we go and talk to our customers, and I'm sure each one of you would be in this journey, where you would say, hey, cloud is the best world to go ahead and implement AI. Yes, it's definitely great to go ahead and run use cases on cloud. You could train on cloud, you could get the latest technology on cloud, but we are seeing once it moves from strategy to scale, that is you start with a pilot of 10 users, now you are an organization with 50,000 users. When you start the use case to implement at scale, then that inference leads to repatriation. What does this mean? Is for inferencing, that realizing benefit of AI, you would have to move your model to edge, to data center, to the user where you are, right? As simple as a chatbot to fetch information in the organization, right? So those sort of use cases are moving from cloud to on-prem. Second key thing is AI is network bound. As it moves to on-premise or it moves towards edge, you need a robust network to go ahead and build that. There'll be more robust security at every layer. The system is prone to attacks. That's where you have a security stack talking about the full stack solution. And you need hyper-distributed security. Security is no longer centered to your data center. Security is no longer centered to your phone. Security has to be everywhere. And then customers need choice of hardware, choice of infrastructure where they want to go ahead and build it. Now, these are few architectural shifts that we are seeing, or depending on the journey you are, either you've adopted AI, or you're thinking about moving to AI, or you're planning in terms of how exactly you go ahead and build this stack, this is where you would go ahead and land from an architecture perspective. Now with Cisco, we propagate AI-ready data centers, which helps you build full stack solutions. We have thought for customers who are building their journey on AI, you need to no longer think about which location. You could start at the edge, you could start at data center, you could start from cloud. We provide the full stack solution to go ahead and build that. So we get into network, compute, AI models, resources, and help each one of you to consume AI as a service. That is outcome as a service. If you're building chatbots for your organization, you're building co-pilots for your organization, or probably you're building a content creation for your organization, all of this is abstracted, and what you get is everything as a service where we help you define the model, build the model, develop the model, train the model, and also observe the model. That's the full stack solution that we offer. We'll get into weeds in the next section. Now, this was about how do we go about and select the model. Second is how do we right-size the model. Okay. Now, like I said, there are a bunch of models that are available in the industry. Depending on the use case, we help you define the model. So we offer AI assessments where we sit across with your set of people, your set of line of business, to go in and understand which model is the right fit. Once we get to the right fit model, I'll kind of run this one simple log of how do you go ahead and infer the model. I'm not sure if you're able to read this, but what is the answer to the ultimate question of life, the universe, and everything? Any guesses? I have prizes who can guess from where it's picked up. No, I'm joking, there's no prize, but any guesses? It's Hitchhiker's Guide to Galaxy that took 7.5 million years to give an output of 42. What is the significance of 42? There's no significance. There's no purpose of life. Each one has to go ahead and define life, right? I've just put that in context of a RAG-based application or an inference application. So this question gets into tokens. What is tokenization? Is simple translation of words into digits, because as computers we still understand digits, right? So it will translate into digits. And then there is prefill. What does prefill do? It will build model weights. What are model weights? That it would start assessing what should be the response for this particular question, right? Once we get into these details, there is something called as KV cache, okay? Key value pair cache. Not sounding geeky, but it's important to understand that how this works. Only then you'll be able to build the right infrastructure for that. It's easier to go ahead and consume something once you're building for 10 users, 20 users. But if you want to scale, you need to actually understand how this works. So then after that, there is decoding loop. Decoding loop is building the analytic capability, feed to the model, and understand how and what response it needs to give. Okay? So these are the steps, and ultimately it's de-tokenization. That's where we get the output. And for this question, we all know what's the output. The answer is 42. What does 42 mean? There's no relevance, because everybody has to go ahead and build his own purpose of life. Now, why did we run through this? As part of this journey, you have to figure out the longer the prompt, okay, the bigger the KV cache. The larger the KV cache, the longer time it takes to respond. That is what is important. Today, if I log into ChatGPT, I don't get a response, I'll be like, no, this is not usual, right? So that's what typically called as time to first token. That's the response time that you're looking at. What is the goal once you design this infrastructure is to optimize memory, performance, and cost. So whenever we think of operationalization or model efficiencies, we need to think about how do we optimize cost, performance, and memory so that we are able to go ahead and build this stack. I've built I'm sorry this slide is not visible, but I built an inference model. So there are two things that I want to talk here. One, as Cisco, we've launched a security foundation model where you as users could go ahead and access that. This is available on Hugging Face. Please go ahead and download that. Cisco has two models listed. One is with Foundation Sec 8 billion parameter model, and second is deep learning model. What does this do? The Foundation Sec models helps you go ahead and minimize attack surface. If you're looking for a right security model for your organization, this is the model that you should go for. What does deep learning model do? Deep learning network model is our analysis of all the Cisco devices that are available, helping to get root cause of this overall stack. So these are two models. The Foundation Sec is available on Hugging Face, 8B model. I highly recommend for users who are playing around in the security domain, please go ahead and do that. Now, why this model is important is how do you size the overall setup? One is just raw size, that is, this is the model with 8B parameters. You generally need precision rate. So this security model is built at BF16, which is 2 bytes. So what do? The model is 8B into 2 bytes. So you need 16 GB of memory. Now there is a purpose that we are talking about. GPUs are the most expensive resource today, right? You can hedge it against any of the metal stock market. You'll see that GPUs are the most expensive resource today. We would love to sell truckloads of GPU to you guys, right? Because that's what we do for a living. But as customers and as people who want to adopt AI in the right fashion, you need to understand optimization of this stack. Now, to understand optimization, you need to understand the space of what's the raw model size. And there is an alternate method. If you see TensorFlows as part of this, you could go ahead and multiply that. So it's roughly the same. In general, size of the model and then the precision that we are doing, just multiply that, you'll get the average memory size that you have to build. Then I talk about, we've spoken about something in the prompt of KV cache, okay? So there is an importance of KV cache and context length that goes along with this overall ecosystem. So there's a formula here. I don't want you guys to learn the formula, but I want you guys to think through when you're deciding a model and selecting a GPU, rather than just blindly go ahead and saying that, hey, this particular thing will require a 288 GB memory or 192 GB memory and so on and so forth. So with this, you get into per stored token, and basis that you can arrive at a GPU memory. Now, why are we doing this? You'd be wondering that, hey, I'm just bothered about my front-end application. My front-end application is, I need to build RAG. I don't want to get into all of these details. Cloud is the best way because it allows me to go ahead and build that. But once, like I said, I'm at the cost of repeating. Once you start from 10 users, go to 50,000 users, all of the costs start hitting you. Then you'll get constant emails from CIOs. Hey, what are you doing? I thought it's a simple knowledge chatbot or a knowledge copilot application. What are you going to do going ahead and building that? So this is why we get into the details of how exactly you decide the memory for your GPU from the model perspective. Now we've decided something on memory stack, and I spoke about knowledge copilot. So this is a RAG inference example for a knowledge copilot. For my particular model, I required only 33 GB of memory, okay? In that 33 GB of memory, there are other things that you need to think about, right? It's not just about the model. Once you start building your knowledge copilots, you would realize that you need now embeddings. You need vector database, okay? Then you need your data. For all of this, you need infrastructure to go ahead and build this stack. These are few costs, these are few These are few things that gets missed out when you start building when you start building something on your laptop. That you feel, hey, I've built, and I personally have 2 models running on my laptop, and I can create a RAG chatbot there. But as you move to scale, these are the things that start hitting. So what we've helped, or what Cisco is helping build, is something, a packaged solution where you could go ahead and host these models as part of your infrastructure size. So that's the reason there was a context of understanding the LLM, understanding your model, understanding that how you are building it, no matter you're from application side, infrastructure side, network side, and so on and so forth, this is the language that we all need to understand. And again, I pick up that thought from Malay. He said that all of us need to upskill ourselves. This is the new sizing, this is the new norms from a best practice perspective when you start building your infrastructure. A shameless plugin of Cisco product. Now, this is what we help go ahead and build that. We provide full stack observability with Splunk observability platform, where you can go ahead and exactly assess what's your token usage, what's your response time tracking, that once you've built that model, selected the model, optimized that model, built it on a GPU, then how do I monitor? So this is how we go ahead and build that. Token usage per user, response time tracking. You can set cost analysis, and you can go ahead and build your own use cases or KPIs where you need full stack correlation. You can add this to how many marketing users have accessed this particular model. How many finance users have done that? What was my token response time for this particular project, and so on and so forth. So that's the art of possible with AI Observability Cloud hosted on Splunk, right? Now, getting into, we spoke about models, we spoke about how do you go ahead and build this stack, then what has Cisco to offer to help you build this full stack ecosystem? So Cisco offers full stack compute networking portfolio to help decide the right sort of infrastructure that is required to go ahead and build this stack. So we put across GPU accelerated systems, which is building the model or your data sets that you have to go ahead and build. Second is around GPU optimized system, if you're looking to optimize a particular model, which is the use cases of RAG. And if you're, like I said, inference repatriation is happening for real. So if you want to do inference at the edge, we offer inference optimized edge-based solutions where you could go ahead and use the model. Now, if you are from an application side or you are a data scientist to say that I am just not bothered about infrastructure, why are you talking to me about infrastructure? I need to consume APIs, I need to consume tokens. Can you just help me do that? Then for them, we offer a package solution called as Cisco AI Pods. What does Cisco AI Pods help? We help customers use the model with full stack ecosystem, which includes compute, it includes GPUs, it includes drivers, it includes networking stack, GPU stack, observability stack, and help you deliver token as a service where you want to go ahead and build this stack. So there are multiple ways. The way we want you to lead is choice of infrastructure rests at your hand, and you could go ahead and build the overall stack. Now let's get into details of what I said is we'll talk about network because our bread butter eventually is network. Let's get into some details of how do you go ahead and why do we need 2 GPUs or 4 GPUs? This is one of the most common question that we get with customers. Hey, I've done my sizing. I've seen I'm using a Llama 8B parameters, and the memory, GPU memory that I require is just 33 GB or 40 GB. Why do I need bunch of GPUs, or why do we see, or why do we start hearing data centers of football size data centers? Why exactly this works? Sorry. So there are 2 different ways that you consume this stack. Show of hands, how many of you heard about the Llama 405 billion parameter model? Thank you. So once the model size increases, you need to split that model, right? There are 2 ways to split the model. One is you split the model within the GPUs, or you split the model across 2 GPUs, okay? And both are not mutually exhaustive. Both happen in your infrastructure depending on how do you build that. So 405 billion models, within the GPU stack, when you go ahead and split that, there is a switch internal to the server. This switch connects each of these GPUs at 900 gigabytes per second. That is how you are able to run faster, okay? 900 gigabytes is a lot of bandwidth. So depending on your model size, you start building it within the server, and if you start building a bunch of GPUs training that model, that means now you have to move from one server to other server, and then to subsequent server, and so on and so forth. So that's where the model has to talk outside of the server also. Are you all with me? Model talking inside to the server when we split, and because the models are heavy and training precision is required, then we go ahead and build outside the server. That is where connectivity becomes one of the most important factors going ahead and building this stack, which is popularly called as NVLink switches inside the GPUs and Rocky V2 communication outside the GPU systems, okay? These are two key things you need to remember. Rocky V2, we all have seen KGF, Rocky Bhai. I generally say that Rocky has become the Ethernet. Rocky Bhai has become the Ethernet. In the Ethernet world, Rocky V2 has become so popular, right? So Rocky V2, RDMA over converged Ethernet. That is what we offer the best. We've been doing this from decades together to go ahead and build that. This is how one physical server looks like. When we think about data center sizes of a football field, these are the compute platforms that are stacked across physical racks, be it air-cooled, liquid-cooled, so on and so forth. These are the systems, heavyweight systems of 15 kilowatt stacked across the racks to go ahead and help build this strategy, okay? Now, this is where there is communication that gets into picture. Front-end communication, back-end communication, GPU communication, and so on and so forth. So this is where we talk about external connectivity. Again, tying this back to operationalize the model. I took an example of 8 billion parameters, but if you start building 405 billion parameters, you start building 70 billion parameters, and now with XAI, I heard that they're doing 1 trillion parameter models, then you need to understand and get this stack as part of your overall, as part of your overall ecosystem. This leads to network design. You need a tightly integrated, engineered system so that you get the right response or right latency of TTF, the time taken for first token, TTFT. That means I'm responding, hey, what's the purpose? I'm asking a question, what's the purpose of universe? Then to get that response, the first response is called as time taken. That's the first token. So I need to build my network in a way where I can reduce this, optimize this, so as a user, I am happy. When I go to Perplexity, I go to ChatGPT, I need the responses immediate. I don't want to wait for a longer time so I can get the responses. Now to do this, you need to design the network in the right fashion. It could be inference, it could be training, or it could be just general requirements. Like I said, it all starts with data. If I have to build my chatbot, if I have to build a knowledge copilot, or I have to build like a knowledge code assistant, then I need to have right data set. I can build a chatbot without the data, it will not mean anything. It will give garbage in, garbage out, right? So you need the right data. Classic example, if I am a sales guy at Cisco and I need a model to go ahead and predict what is going to be my forecast, I need to send the model that, hey, this is the data. This is what was there as part of as part of my earlier forecasts. Only then it will be able to predict. In general, if I go ahead and say, hey, give me the forecast, it will definitely give a number, but it will have no correlation. That's where the heart of things start with data. You need to have your data cleansed. Now, data would require certain type of infrastructure, which is networking and compute stack to go ahead and build this journey. Once you have the data, then you feed the data to the model. That is where training happens, okay? Training is network intensive and data intensive design where you need to define your network. So general requirements of training are high bandwidth because there's a lot of data. And like I said, one model with bigger parameters needs to talk to next GPU, needs to talk to server at the next GPU, probably a server in a different server hall altogether. So you need non-blocking. What does non-blocking mean? That it should talk seamlessly with zero latency, no loss. So these are typical training requirements that go ahead and that go ahead and fall as part of training requirements, right? Now, from an inference perspective, what is inference? Once I get my output, that is inference. To get inference, I need a low latency kind of requirement, so that when I'm inferring something, I should get that immediately. In our example, Hitchhiker's Guide, what's the purpose of life? I should immediately get 42. I should not have to wait for 7.5 million years to kind of wait for this particular, wait for the output. So that's the inference requirement, which is lower latency to go ahead and build that. And then as part of your data center, you'll have generic requirements. Whatever I'm building, I should be able to visualize this. I should be able to monitor it. I should be able to see what's happening when data traverses from one GPU to other GPU, or data traverses from one switch to other switch. I should have enough amount of visibility and telemetry so that I can understand what's happening in my data center. Otherwise, there's no purpose. If I'm building something with no visibility, then it doesn't mean anything. That means it can break any time. It can act funny at any time. I will have no root cause analysis to go and build this overall stack. So these are few key requirements from a networking perspective. Now, we cannot run network as isolation. There is model. We spoke about the model. Then we spoke about the compute stack. Now we are talking about the network stack. These things do not work in isolation. All of this has to be tightly integrated between software and hardware. Now, this is the typical cycle or a typical platform that you would go ahead and build. You see this, these are a bunch of GPU stack. It will have NIC. NIC is an interface card where you go ahead and you go ahead and build that. Then you will operate all of this with Kubernetes, CUDA libraries, NICs, and frameworks. Again, I have prizes for anybody who can remember these acronyms, CUDA, NICs, and there are a bunch of them, right? Why these are important? If you start building stack without taking into consideration how you're going to access it, you are bound to fail, right? So you need to understand correlation between Kubernetes pod. It's easier to go ahead and access something on, say, Amazon Bedrock, and hey, build this particular model. But once you get into the infrastructure side, you need to understand or correlate Kubernetes, CUDA libraries, NICs, which is NVIDIA collective communication libraries, and the AI frameworks that you need to build as part of the overall stack. So this essentially travels, the full stack travels from one system to other system, from one particular compute network to the switch, to the switch and the compute network, which is there at end of your row, which is end of your data center. So anything can happen there. So all of these are tightly integrated. Okay. Now this is a design which is most popular, and this is what is most recommended from NVIDIA and other providers who provide this, who provide accelerators. It is popularly called as Rails design. Now, why a Rails is important is to adhere to the requirement that we mentioned, which is non-blocking design. Each server gets the right amount of bandwidth so that we are able to build full stack solution, essentially helping customers to achieve full Rails or a full design to get your training infrastructure done, right? So that's a brief about the Rails design, what we go ahead and build, why we go ahead and build this stack. Now, it is important to understand that how one particular switch communicates to other particular switch. These switching happens through packet spray. What does this mean? I have a model. This model has certain parameters. This model has to talk to another set of server, which happens over packet sprays, right? So we spray the packet. Think of it as a huge train. We want to send folks in the bogie where there are seats available. We don't want to send folks which is overcrowded. If a train bogie has 72 seats, I don't want to send 73rd person in the same bogie. I want to send somebody in a different adjacent bogie where there are enough seats available. So that is what we build with packet spraying or per packet load balancing. Now, all this complex technology that I spoke so far, it is difficult to build if you start building each and every component as stack. I've just touched 10% of what all goes as part of building this design. So for this purpose, what NVIDIA is built is called a reference architecture. Okay? So there is an enterprise reference architecture and a cloud reference architecture. If you're an organization who's building knowledge co-pilots up to 1,000 GPUs or any of the use cases, it falls under reference architectures. And if you're building beyond, it is a cloud reference architecture, okay? Why are these reference architectures built? Is to promote sovereign AI. That means I want to build everything locally in country, including my data and data centers. Like I said, data is the key. You need your data centered in a location to go ahead and build this stack. Now, as Cisco, we are the only networking vendors that go ahead and build a reference architecture along with NVIDIA, calling it as Cisco Enterprise Reference Architecture. How does this help for people like you to go ahead and consume this is if you're building any AI application and you're stuck in this journey of how do I define the model, how do I help operationalize the model, which GPU stack to select, which GPU vendor to select, which compute platform to go ahead and build, which networking platform to go ahead and build, we help go ahead and package all of this together in a form of Cisco Enterprise Reference Architecture, right? Are you all with me? We started off, we touched upon full stack AI journey, right? And that's what we wanted to cover in terms of how do you operationalize this AI and what are the best practices to go ahead and build that. As customers, we give you options of 3 stacks to go ahead and build this. You can build custom, which is build your own solution as part of your data center. Second stack is we help you build this as a service. I started off with a section that Cisco is helping build as a service offering where you don't have to bother about anything. You don't have to bother about all of these complex terms that we spoke about. You just have to consume token as a service. So those token as service stack, we can help you go ahead and build as part of a SaaS-based solution. So we can meet you where you are. The choice of stack retains at your end. So these are reference architectures which are published online. I would strongly encourage to go ahead and get well versed with these reference architectures that we've built. Now, most important aspect once you've built the design is security. How would you go ahead and minimize attack surface? Today, even if I install a model on my laptop, I'm prone to an attack. I don't know from where I'm downloading the model or from where what exactly happens when a user goes ahead and accesses a particular model. I'm not really sure what's the source of the data. I could go ahead and ask, as an organization, I can go ahead and ask that, hey, what's X person's salary? The model is not supposed to give those details. So those are certain guardrails. So you need to embed security at each and every layer that you go ahead and build, which is embedding security at access, preventing customers access. Second is preventing customers in your infrastructure stack, that how do you kind of protect them. And third is preventing customers to build malicious models. So we propose a hybrid mesh firewall that helps protect all of these 3 solutions, where you can protect your users and customers at the edge, you can protect them at the data center, you can protect them at the model level so that you're able to go ahead and build full stack solution for security stack where you have visibility and you can build with confidence that each of the layers that are there which is protected. Now this is standard stuff which customers have been doing. What we do differentiated is we provide a single security posture for edge, for data center, or for cloud so that we are able to give full stack visibility of the security stack. We have expanded this solution to a portfolio called as AI Defense. AI Defense comes from our acquisition of Robust Intelligence. How does AI Defense helps? It gets onto the model level. If you're running, if you've downloaded Llama 13B parameter, 70B parameter, or using OpenAI, or using a model on Azure Stack, or you could go ahead and leverage this so that you are able to go ahead and detect in case there is an issue on model security. We use red teaming algorithm that helps to protect what you are building. Either it could be at the building phase or consuming phase, or it could be at access phase. You could just block that, don't access anything from OpenAI, don't access anything from an open source Hugging Face model, or you could go ahead and build the way that is required, right? So that's the power of AI Defense. This is just a snapshot of how AI defense work from an application perspective. Now, all of this needs to be built together, right? You can run things in isolation, but then you start off with the risk of building this overall ecosystem. That's why you need to start bringing all of this together. This is what we announced along with NVIDIA, is bringing secure AI to your enterprise. We call it as Secure AI Factory. We are the only vendors in the industry who's helping customers realize true benefits of AI in enterprise space, where we get compute, network, security, storage, and observability, helping you build full stack ecosystem so that you can consume your knowledge copilots, code generation, virtual agents, or any use case that you're building comfortably as part of your data center stack. And there are a bunch of analysis that we can share as a follow-up where your return on investments on cloud versus on-prem, once you scale, on-prem works out to be far more better for a bunch of issues: costs, security, privacy, data sovereignty, and so on and so forth. Now, this is how I end my section, because we started off with this full stack, and I have a habit to recap so that we grasp, depending on us, we grasp 10%, 20%, 80%, or 100%, depending on the audience that we have. You could be an infrastructure network guy, compute guy, security guy, or an application guy, then Bits would have helped you go ahead and build that. But this is the section where I kind of recap that we help customers build full stack ecosystem with Secure AI Factory. It starts off with, not with infrastructure. This journey is not about infrastructure. It starts off with model. You decide what's the model. We kind of help organizations decide through Cisco AI assessments. Then you right size the model. We got into details of how do you go ahead and right size a particular model. We help you go ahead and build that model. Then you transpose that model on infrastructure. That's where the compute GPUs comes into picture, okay? That's the discussion all about with NVIDIA, AMD, and a bunch of other hardware OEMs there. That's the third leg. The first two legs are defining the model, deciding the use case, transposing that in your infrastructure stack, building your networking layer, building your security layer, and having this consumed all of this as part of one single stack ecosystem as a service, and observing using Splunk Cloud of number of tokens, what's the usage, what's the posture, what's your department, what's the cost that you paid for the department, and so on and so forth. So I want to leave with Cisco is the only organization that has the capability to go ahead and build that. We are unifying networking, compute, security, and observability, giving the power back in the customer's hands to go ahead and build Secure AI Factory for us. Now, you have any further questions, you can contact me. I think I have 3 minutes left for any questions that you have from the audience.
Taran, very well presented, thank you.
Thanks.
So what I'm getting is, you're actually professing going away from the traditional cloud way versus on-premises way, especially when we have factory of kind of applications where your OT need to be talking to your IT. I understand that that is the classic case for edge computing. But the quandary is that if there is a need for us to raise the GPUs, in cloud it is much more flexible for me vis-a-vis doing it on-prem, because then I would have to go through the entire cycle of procurement and all that, right? How do you solve this kind of dilemma in the enterprises?
Thanks for the question. That's a great question. So that's the reason what we've seen from a trend perspective, right? So once you start the use cases, say you identify 10 use cases which are relevant for your organization, then you start something on cloud because it's easier to access, easier to procure, and easier to test it out. But once you start hitting one, you've decided a use case, now you decide the number of users for this use case, because it's all about concurrency, number of users, and so on and so forth. So if you decide that you want to move from 10 users in your pilot to 50,000 users, you have time to go ahead and plan your infrastructure there, right? So that's where we kind of help cut down certain procurement cycles depending on the GPU sizing and so on and so forth. But that will be you'll have a lead time of 10 to 12 weeks from a GPU perspective. It's far better what was there back in 2022, 2023. But currently we are seeing 10 to 12 weeks is a fair, decent amount of GPU cycles procurement cycles for accelerators that we see in the market. But idea is you need to plan early, you need to define the use case and then go ahead and build that. But if you say that, hey, no, I want to do everything on Prim itself, I don't want to go to cloud, then we have our partners where we can help you ship certain GPUs on your site where you could go ahead and test it out, or you can test something remotely, and meanwhile we can plan the procurement cycle. That's how we're seeing generally.
Great answer. So what you're saying is that we start small with cloud.
Yeah.
We decide what is the inflection point. From that point onwards, we invest in our on-prem
setup.
Thanks.
Yeah,
Okay.
absolutely.
Okay.
Thanks for the question. Yeah.
Thanks, Taran. I have a question not on Cisco, but on DeepSeek.
Sure.
How did DeepSeek build a model which is cheaper than the rest of us? Rest of the other models.
I wish I could crack that and build a model myself.
What's your opinion?
Yeah. See, I think they went. It's just my personal opinion. What they actually went is recoded the assembly. A good part that they've done is they've published this paper online. And if you understand how the models are built, if you kind of go ahead and read that, they figured out a way where they could utilize the GPU has cores also, right? So they kind of built on that assembly, they are able to go ahead and utilize those cores and optimize the model, right? So that's one thing that they've done really well. And if you actually use DeepSeek, and this would be a good analysis for you, ask a question to a ChatGPT model and ask a question to a DeepSeek model. DeepSeek will take more time, and eventually when you optimize these, DeepSeek will take certain extra GPUs. The reason for that, it is built on a reasoning model. That means for this particular question, what's the ultimate guide to the universe? If I publish to DeepSeek, then it will kind of write to one model, then start reasoning of in what context is this asked for, okay? And unless I give the right context, it will keep searching from a model perspective, right? So that's just my perspective about this. But what they've done fascinatingly well is they've repurposed the assembly code of a GPU. So that's a very interesting proposition. And if you look at the new models which have come out from Meta, they've kind of adopted this. And as you see the Indian models with India AI Mission, the current models which are building, they are also kind of adopting the similar stack so that they're able to optimize the set of models that you go ahead and build. They can optimize the GPUs, right? But I understand it created a lot of wave. There are political questions in terms of how did they get access to GPUs and so on and so forth. Without getting into that, technically I think they've done phenomenally well to repurpose the assembly code. Is just my individual analysis there. Again, thanks for that question.
Hey. Hi, Tarandeep. Thanks for the session. So I have a question on GPUs.
Sure.
So GPUs are the most cost factor in this architecture, right? So there are multiple architectures like Ampere architecture, L architecture and everything. So what kind of GPUs do you suggest based on, for example, to run the model, we require a 32 GB memory or a 24 GB memory.
Yeah.
Since NVIDIA provides L4, which provides 24 GB memory, and also RTX 4090 or 5090. There is a consumer durable cards as well as enterprise grade cards.
Yeah.
So to lower the cost, right, people are usually confused, the companies are confused which one to select here for the use cases. So I would like to know what kind of suggestions do you give on choosing the cards?
Yeah. Thanks for that question. So when you actually get into details of which card to select, it starts off with which model. That's the reason I did not, usually as an infrastructure guy, I'm supposed to first talk about infrastructure and they say that, hey, these models are supported. But I started off with the model, started off with KV cache, and then led to the infrastructure stack. The reason for that, if you're running DNN workloads, deep neural networks, or CNN or RNN, those type of workloads, where you're doing computer vision, then a consumer grade or lower end GPUs are right fit. The RTX family that you mentioned, L4s that you mentioned, they are absolutely right fit from a visual analytics or computer vision workloads because they are built on DNN, okay? Now, as you move to Gen AI, right? The model parameters and the way it accesses is slightly different. That's the reason you need to move towards certain GPUs. That's why Volta would not perform equivalent to what we're doing at L40S, and then L40S would not perform to the Ada Lovelace family. And now with Blackwell, you see improvements there. So what you need to look for is which model, what type of neural networks are you getting into, and then transpose that model to a server class family. And you would see that you can spin up anything on Lambda Labs, same model with same GPU size. Do a 24 GB on L4 and do a 24 GB on L40S. The performance that you see on L40S would be phenomenally better for a Gen AI workload, and vice versa. Run a DNN workload on L40S, run a DNN workload on L4 on the same memory. The L4 will just crash because it's not built to reason that way. It doesn't have the, getting into a bit of details, it doesn't have the spatial arms and the GPUs to go ahead and build that, right? So that's the difference as part of that stack.
So thank you.
Thank you.
Thank you very much, Taran, for this amazing session. Can we please have a huge round of applause for Taran?